Okay, everybody, welcome to day one of summer school geometry. I'm Mr. Patel. I'm going to be teaching this course for the next 16 days. And so I hope to do the best that I can to help you recapture all the major concepts from geometry if you're retaking this course. And if you're taking this course for advancement, then I hope that I cover all the concepts that are essential for you to get mastery for this course and move on to Algebra 2 next year and so on and so forth. Okay, so this is day one. In this module, you will investigate angles formed by parallel lines cut by a transversal. So we'll talk about what that is. And then we'll also investigate interior and exterior angles. So let's first start talking about what a transversal is. So right here, here's the textbook definition. And basically a transversal is a line that intersects two other lines. And I'll kind of draw that below, but I'm going to use what's labeled here. So the transversal I'll label as the line T, and then there'll be two other lines, L and M, also in this diagram. So let's first start by, I'm just going to draw two random straight lines. So here's line L, and then I'm going to draw another line. There's M. Okay, so there's lines L and M. There's two random lines. Now a transversal is any line that cuts through two other lines, or it could be more than two, but in this example, we'll just do two lines. So I'm just going to draw another line going across like that. So this guy right here, line T, the red one, that's called the transversal. It goes across the other two lines. So I'll just label that right here. This guy is the transversal. Okay, so when a transversal cuts across two other lines, it forms a total of 8 angles. And you can kind of see those here. I'm going to label them like this, 1, 2, 3, 4. And then if you go to the other intersection, 5, 6, 7, 8. So 8 angles are formed here. This is very similar and applicable to the real world when, if you look at a map from bird's eye view, like if you go into Google Maps, you'll see a lot of roads intersecting. And sometimes if you look in downtown of major cities, you'll see that the lines or the roads intersect at different angles sometimes. And so this is applicable and useful to know for situations like that. So if you see this type of situation, this is a transversal here. These 8 angles are formed. Now, when we have these types of angles formed, we have what's called the interior angles and the exterior angles. So if you think about these two lines, the blue and the green one, line L and line M, anything that's between them is called an interior angle. So I'm going to shade this part in on the inside. Okay, so this color inside of here, this shaded part right here, this is what we call the interior. Okay, so that means that 3, 4, 5, and 6, those are interior angles in this situation. And then I'm going to also highlight these guys out here. Anything on the outside of the two lines, those are called exterior angles. You could probably figure that out. So here's the exterior on this side, and then the exterior down here on the outside of line M. So you got interior and exterior angles. So now we have a bit of more vocabulary to understand, or you might remember this if you've already seen this a couple of times before. But if I were to look at angle 4 and angle 6, for example, 4 and 6, they're both on the interior. But now if you think about where they are in terms of the transversal, if this was a road, and you're thinking about number 4 and number 6, they're on alternating sides of the road. They're on different sides of the roads. They're not on the same side. So angle 4 and 6 are what we call alternate interior angles, because they're on alternating sides of the transversal, but they're still on the interior of this situation here. Then you could also think about angle 1 and angle 7. 1 is out here on the exterior over here. Angle 7 is on the exterior, but it's on the alternate side. So this would be called alternate exterior. Then you could do the same thing for other angles, like 4 and 5 would be alternate, sorry, not alternate, but same side, because they're on the same side. 4 and 5 would be same side interior angles, or you could think 1 and 8 those are on the same side of the transversal, but they're on the exterior portions. So you can look at different types of situations, and that's how you would refer to these angles. Okay, now let's talk about a few examples down here. In this first problem, what we want to do is we want to figure out what are the value of each of these angles. And now let's talk about a situation when you have a transversal going through parallel lines. See these two markers right here? Those little extra arrows in there means that these two lines are parallel. Now there's special things that happen when you have parallel lines in a transversal. When you have parallel lines, your angles that are right next to each other, they're always going to be supplementary to each other, meaning they're both going to add up to 180 degrees. So right here, when we're trying to figure out what angle 3 is, I'll put the measure of angle 3 is equal to, and if we want to figure that out, I already know this is 43 degrees right here. This angle right in here is 43 degrees. But if I wanted to figure out angle 3, it would be 180 minus 43, because we want to figure out what this remainder part is right here. Or you can think about what plus 43 would equal 180. So here we have 180 minus 43, and this is going to be equal to 137 degrees. Okay, and we can continue to go around to all of the angles and try to figure them out. Now, it's kind of becomes a little bit easier as you work throughout the entire problem. If you know angle 3 is 137, then the same thing could apply for angle 1, because these two are opposite angles. Opposite angles are always going to be congruent to each other or equal to each other. So I'm going to put measure of angle 1 is also equal to 137 degrees because it's right across from angle 3. Same thing holds for angle 2. Now you could say 43 is going to be equal to the angle it's opposite from or across from. So angle 2 is also going to be 43 degrees. And then the special part about parallel lines is that these angles are going to be congruent to these angles down here. So angle 5 corresponds to the angle up here, that's 43. Angle 4 corresponds with angle 1. 6 corresponds with 2. 7 corresponds with 3. They're on the same location of that intersection. So I'll just briefly write that down here. I'll write one example. Angle 1 and angle 4 are corresponding angles. All right. Let's try another example. Once again, right here we have parallel lines, and we need to figure out what angle 1 and 2 are. We don't know what these guys are. Angle 1 and angle 2. We're trying to figure out what those guys are. And so I need to use whatever else I know in this problem to figure that out. Okay, so one special thing about parallel lines is that if you have same side interior angles, notice how these two angles, angle A and angle D, are on the same side of, this would be the transversal if I would extend it going outside of the shape, and they're on the interior of the two parallel lines. So angle A and angle D, since they are interior angles of two parallel lines, then they're also going to be supplementary to each other. They're also going to be equal to 180. So measure of angle 2 is 180 minus 50 degrees, which is going to be equal to 130. So angle 2 is 130 degrees. Since these are alternate interior angles, if I were to extend this line going like this, and then we think about BC as the transversal, now we see that angle B right here on this side and angle 1 right here, we would say that those two angles are congruent because they're alternate interior angles. If you have parallel lines, the alternate interior angles are congruent to each other. So here we can say that the measure of angle 1 is equal to 95 degrees alternate interior angles when you have parallel lines are going to be equal to each other. All right, let's look at one last example here. Okay, this one involves two algebraic expressions. If I think about these two parallel lines right here that are going across with these little arrows, those are parallel. This angle here and this angle here, we have corresponding angles. They both kind of look the same. If I were to, let me trace this angle right here. I trace that red one. I can move that and I can place it on top of this bottom angle and it's going to be the same. It's going to look the same. So what that means is that they're going to be equal to each other. So I can say 3x plus 6 is going to be equal to 4x minus 12. And since this is an equation, I can solve for x. Just use my Algebra 1 skills and let's solve for x. So let me collect my x's to the same side. So if I subtract 4x this way, I'll get negative 1x is equal to, and if I subtract 6 this way, negative 12 minus 6 is negative 18. Divide by negative 1 on both sides. So x has to be equal to 18. But this isn't what we're looking for. We want to figure out what's the angle measure. So I need to just take 18 and plug it into here. Now what you need to do is look in the module on Canvas, and you're going to log into Delta Math, and you'll complete all the problems for Delta Math today for day 1. It's going to have everything to do with transversals and angles. If you have any questions, don't hesitate to email me. My email is right here. Feel free to reach out if you have any questions.